After the discovery of the Higgs boson, many questions about the universe remain open. Physicists struggle to find hints leading to their answers. Since 2013, LHCb, one of the huge detectors at the CERN International Laboratory, started to produce surprising results. These anomalous results might change our understanding of the universe. But are these data real, or just experimental artifacts? In the spring of 2019, a key release of new data has just happened. At the University of Zurich, theoreticians and experimental physicists debate to understand the significance of the anomalies in view of the new data.
So Nico, what do you think?
In one word, inconclusive. And this is why many people, including myself, are disappointed. And I believe that a large part of the community starts to become pessimistic about the fact that this could be a real breakthrough in particle physics.
I don't agree. I don't share this pessimism. It's true that this result is inconclusive, but I don't think there is any reason to be more pessimistic than we were before this measurement. The probability of a discovery is exactly the same that we had before. I'm stunned by how emotional is our community.
Yeah, in the end, this is exactly how particle physics works. Some discoveries are very rare. You usually have small deviations or evidence that start to pile up with time that suddenly, at some point, will converge into the real fact. And I think we might be actually in the exact situation that we are facing now.
Okay, so let's try to understand what happened. We have the Standard Model, as you know, this beautiful theory that describes very well the nature of the elementary particle and the forces through which they interact. And we know that this theory works very well, has been tested by thousands of experiments, but we also know that this theory is incomplete. In particular, it doesn't tell us why different particles have different masses. These anomalies observed by the LHCb could be the first hint of a new interaction that could address this fundamental question.
And indeed, we do have two anomalies, Gino. The one we're considering now consists of a B quark decaying into an S quark and a pair of other particles. In particular, an electron and an anti-electron, and a muon and an anti-muon. The Standard Model, as you said, has a very clear prediction. Predicts that the frequency of this process and this process is the same. Therefore, this ratio that we call Rk should be 1. What we have observed in LHCb is a deficit of muons with respect to electrons. Therefore, this ratio appears to be smaller than 1.
And the best way to visualize this is put in a probability plot. What we have here are different values of Rk, so the ratio between muons over electron, as a function of the probability. So in the Standard Model, you expect this to be precise at 1. However, as Nico pointed out, the first measure of LHCb was actually showing a depth of muons over electron, and therefore it pushed the value to be below 1, to this value here. But when actually we perform measurements, we have associated to it some uncertainties. So the best way to see these here would be in this kind of probability curve. And the value here that you can see here on the top is just the most probable value still, but there's still some chance that these to be compatible with the Standard Model. These are the order 2 to 3%. And in order to go further and make a claim of discovery, this probability has to be below 1 in a million.
Yes, and the new measurement is around here with a probability curve like so. Therefore, while the uncertainty is reduced, it's also closer to the standard model, and the irony is that this probability is still 2 to 3%. That's why I say that the new measurement is basically inconclusive, unfortunately.
This is inconclusive, but I think there is no reason to be more pessimistic than before, because you see, we have to remember that we know very well what is the standard model value, which is 1, but we don't know which can be the value beyond the standard model. Any value of R here, clearly different from 1, can be explained only by a new force, and this will be a major discovery. This is still highly probable. And actually, a value like this one here, if the result will have a smaller error, it fits even better with our theoretical model. So I think the situation is still extremely interesting. I mean, if the data will converge to this value here, this will be a major discovery.
And I think the obvious question now is, where do we go from here? And the simple answer is, we need more data.
Yes, we need RK updated with the full run too.
Yes, I think RK style. Also, this combined analysis with the angular fit, I think, could be a very interesting thing, because
But somebody told me actually that